Alright, this is Unit 1 Functions. This is Day 6, Transformations of Functions. What I have listed out right now is the functions that are deemed parent functions. We look at these functions as the basic types of all functions, that all functions are simply transformations of these functions. I've got the names for a few of them. This is called the constant function. Right here on the first, y equals 1. Not really typical to see that one described as a parent function. I just included it because you need to know that there is such a thing as a constant function. That's where you have no variable of x. Those are always going to be horizontal lines. Y equals x, that is our parent function of all linear functions. Y equals absolute value of x, and obviously that's for any absolute values. Functions. And y equals x squared are for any quadratic function. And what you've got now is a cubic, which we'll be learning about later in this class. Y equals root x, which we learned about in Math 2. This is the equation of a circle, x squared plus y squared equals 1. This is a hyperbola. It's actually a rational function, y equals 1 over x. I've also called it inverse variation. And this is a hyperbola. This would be more of a pre-calculus topic. X squared minus y squared equals 1. Anyways, today we're focusing on these three, y equals x, y equals absolute value of x, and y equals x squared. Those are our parent functions that we're going to use in these. All of these are going to follow the same rules of transformations. For this first example, I'm going to describe the translation of y equals x plus 1 squared minus 2 as a transformation of the parent graph of any quadratic y equals x squared. Now, to do that, I'm going to actually be thinking about vertex form. Y equals a times x minus h squared plus k. And see that the value of a here is just a 1 in this problem, meaning that's actually not been changed on this problem. It's not been reflected because it's not negative, so I don't have to deal with that kind of nonsense. I have to focus on the plus 1 and minus 2. That actually creates what we call a translation. In this particular problem, the graph of y equals x squared has been translated to the left 1 unit, excuse me. And that is because of the plus 1. That's because h would equal negative 1. The k value is negative 2, so it went down 2 units. So, I forgot the word translated. You should include that. And down 2 units. This is the answer for the problem as far as describing the translation. We're going to graph the function. I'm actually just going to graph it on my calculator and make sure that's what it looks like. As you can see, I've already typed it on my calculator, so now I'm going to hit the graph key. This is the new function. And what I like to do is graph the parent function as well. With these newer calculators, they operate in colors, so it's actually a little easier to see. But what I can see is that every point in the red function has been taken to the left 1 unit and down 2 units for each one of these. And that's what I'm really looking for to kind of confirm what I described as the translation. The shape of the parabola is exactly the same. It's not been stretched or compressed vertically or horizontally. Also, it's still opening up for the blue one, so it's not been reflected in the x-axis. Those are the typical transformations that you're going to see for these problems. I'm giving this as a handout in class, so you're going to have to get used to recognizing these things. Whenever values have been directly added or taken away from the value of x inside the parentheses, that's going to be moving it left and right. As far as values outside the parentheses being added to the function, that would be added to the whole function, that's moving it up or down. Negating the function reflects it in the x-axis. Only negating the x reflects it in the y-axis. That's going to come later with our cubic function, so you're not going to see that really happening right now. When the entire function's been multiplied by a dilation factor, it gets stretched or compressed vertically. If only x is getting multiplied, that's a little differently. It's getting compressed or expanded horizontally. But notice that this is flipped. That if the value is greater than 1, that's compressing it horizontally instead of stretching it like it does vertically. Same for if it's between 0 and 1. So all these are this is the list of transformations. If you're describing a graph as a transformation, this is what you refer to. In fact, I can't think of a time where it's something outside of this list for any of the functions that we deal with. So now I'm going to describe the reflection that's shown in y equals negative absolute value of x. Kind of goes ahead and gives it away that this transformation is in fact going to be a reflection. Now, let's take a look at the negative, whether it's on the entire function or whether it's only on the x. Now this one is on the entire function because not just the x is getting negated, the entire function's negated. The negative symbol is outside of the absolute value. When that is the case, the entire function is being negated. Now let's go back to our list here. When the entire function is getting negated, that's a reflection in the x-axis, meaning now this graph's going to be going down. All right, so now I'm going to go ahead and write that in, that this is a reflection in the x-axis. And in fact, if I was to graph it out, 0, 0 would still be a point, but at 1, it would now be down at -1. At -1, be at -1. And then it continue on linearly from there in both directions. There's my absolute value graph for this particular problem, as opposed to the parent function, which I just drew in green. It's a reflection in our x-axis. All right, that wraps that problem up. All right, this is the most intense problem I'm going to show you because it has absolutely everything happening to it. Now, I'm going to start off with any reflection that's going on. The x has not been negated on its own, so it's not reflecting in the y-axis. However, there is a negative being applied outside of the parentheses. Because of this negative, the entire function is negated. This is being reflected in the x-axis. It's now going to open downward. So I'm going to make a quick note of that transformation. Reflected in the x-axis. Anytime that you see a negative a value, you know it's reflected in the x-axis. Now we're moving right along. Has this been stretched or compressed vertically? And the answer is that it's been compressed vertically. The reason why I know that, the a value is between 0 and 1. It is 1/2. Now some of y'all might be saying it's -1/2. The negative has already been applied in reflecting it in the x-axis. So as far as transformations go, don't think about that negative anymore. Because this value that's applied to the entire function, by the way, not just the x, it's impacting the whole thing because it's in front of the parentheses here. Because it's less than 1, it's being compressed by a factor of 1/2 vertically. All right, now let's move on to the translation that's occurring, and in fact there is one. First of all, because this is x minus h, if you'll look back at your list, this is the very first blocks, first two things in the first block, where it's minus h or plus h. This 5 is only being applied to the x, not the whole function. So the fact that it's a minus 5 is actually going to be moving to the right because it's going to be minus h. H units to the right in this case because minus means you're going to the right for left and right. So it's being translated to the left, or excuse me, right 5 units. See, I'm getting it backwards right there. Last thing that we haven't dealt with yet is the 12.5. The 12.5 is being added to the entire function. It's f of x plus 12.5. It's the kicker at the end here. Because it's added to the whole function, that impacts how far up or down it's going, and this one's going up. It's the k value in that chart that we looked at a moment ago. So since it's plus 12, it's going up 12.5 units. Now in class we're going to graph this on the calculator so you can see that. You can do that at home and see what it looks like compared to the parent graph. All right, and here's our last example, I believe. Yes, it is. So with this last problem, we're just going to describe the transformation and graph. And again, leaving the graphing done in your calculator, you can take a look at it there. This one is not being reflected. X is not negated, nor is the function negated, so it's not being reflected. No reflection happening here. Now, the 3 is impacting it by stretching it vertically. Again, if this scale factor is outside the parentheses, or in this case, outside the absolute value, it's impacting it vertically. All right, so it's stretching it vertically by a scale factor of 3. So I'm going to write that in here. Okay, got that written in. Now let's talk about the +4 and the -2. Again, that's your horizontal translation and your vertical translation. So horizontally, because it's +4, I have to negate that. It's going to be actually going to the left. It's going to go left 4 units, and then it's going to go down 2 units. Now I have that written in. That's all the transformations that are happening for this function. All right, I did give a handout of the transformations in class, so if you weren't there, please ask me for that copy. And if you've got any questions, please let me know. Thank you very much.